This is Norm Christofferson, Senior Trainer with Johnson Controls. In this session we will answer the question, how do we read and set the address of a controller? We will use an FEC controller as an example. Each controller has a switch bank containing a row of 8 switches. Ours is the red switch bank shown here. The real name for this set of switches is a DIP switch. DIP stands for dual inline pin, or as some people call it, dual inline package. DIP switches are very common on all kinds of direct digital control devices and can be found on all sorts of electronic equipment, and they are used by many manufacturers. Controllers in a network each need a unique address, so we assign each an address using its DIP switch. Direct digital controllers are called digital controls because they are binary devices. Binary and digital mean the same thing. Bi means two, like in the word bicycle, meaning 2 wheels. Digital controllers are digital or binary devices, so we give them an address using binary on or off switches. Although our interest in this lesson is controller addressing, I want to point out that all the logic and software functions inside of a controller are accomplished using the binary numbering system. Direct digital controllers, or DDC controllers, are given that name because they are binary operating devices. So what do we mean by the binary numbering system? Well, the base 2 or binary numbering system is quite different from the base 10, which is the numbering system that we are all familiar with. In the base 10 numbering system, all numbers are represented using the digits 0 through 9. In the base 2 or binary numbering system, all numbers are represented using the digits 0 and 1. Each 1 or 0 is called a bit. Our base 10 system uses 10 digits, 0 plus 1 through 9, to represent any number that we want. When one placeholder is filled, we add another placeholder to its left and begin again. This is the base 2 system. We can only use a 1 or a 0. Each placeholder can only have a 1 or a 0 in it. On the far right we have the 1's place. To its left is the 2's place. To the left of the 2's place is the 4's place. Each place represents a value that is twice that of the place to its right. So the place to the left of the 4's place must have a value of 8. In this example, the number represented in base 2, or in binary code, is 5. A 1 in the 4's place is worth 4. A 1 in the 1's place is worth 1. 4 plus 1 equals 5. Here we have 8 placeholders. Each place has a value twice that of the place to its right. To read the number represented, we add the values of each placeholder with a 1 in it. Here 4 plus 2 plus 1 equals 7. Let's look at another example. We add up the values of each placeholder that has a 1 in it. In this case, the values add up to 151. If this number represented an address, the address would be 151. Here is our example controller again. The red address switch is our row of 8 switches where we set the controller's address. Each controller on a network needs its own unique address. No 2 controllers should have the same address. Here is a closer look at the DIP switches used for addressing. DIP switches are usually set at the time of the controller's installation and then left alone. The switches are small and sometimes difficult to see, so a flashlight might be handy. Finally, here are 2 examples of DIP switch addresses. On the left, the switches that are turned on add up to a total of 69. 64 plus 4 plus 1 equals 69. In the example on the right, the address is 11. One quick tip before we go. If you change a controller's address while the controller is powered up, you should recycle the controller's power. The controller learns its address when it boots up. So there you have it. You now know how to read and set addresses on a controller. This is Norm Christofferson. Thanks for watching.